Hello everyone, welcome back to Byte Nexus Tech. So in today's video, we are going to discuss basics of the functions in C programming. Okay, so I hope you all know in every C program we have the uh, main function. Okay, without main function, whether C program will execute? No. So it means that there should be at least one function should exist. That is main is must. Main function is must. Then only C program will get execute. I hope you understood this one. Okay. So main is also one of the function. Okay. Then we have the printf, scanf. Okay. This printf will print on the output on the screen. Scanf will take the input from the user. So these are also functions. Okay. Functions, these are functions. What we are doing here, we are just calling them here. Okay, whenever we are needed it, then we are calling it. So it means if you are calling, then somewhere this function has defined, right? So where it has defined means, as we have written, we always write here hash include stdio.h. Okay, this is the header file. So these are these printf, scanf, and many more functions which we are inbuilt functions which we have already means not we already it has been defined in this some C libraries. Okay, this header file, whatever this include dot stdio.h we have written here, right? So in this library it has already defined. So then only we are calling and using here. So what's the function meaning now we can understand by this. Function is a block of code, okay, that used to do specific task or to perform certain action operation. We use a block of code and we call that. So that this is called as the function. This is just a definition, book's definition, but in real world how we use it, I'll explain you in the next page. So some points are there. So function is nothing but you can define somewhere, okay, and call at any place multiple times. Okay, so how this one we'll see in the next page. So let's take I have one function, okay, int main, int some function will write, I mean so sum will write int a and b, two variables are there, and let's take int sum. Okay, I'll initialize it with 0, then sum equals to a plus b. Okay, so a plus b, and here only let's define a and b instead of taking again int a equal to 10 and b equal to 20, let's take. Okay, so now I'll here print sum is the percentage d, that is sum. Okay, and return 0. So I hope you know this one. Int means it is a return type. This is the main is the function name, and whatever we are returning, nothing we are returning. So as a 0. So to make in a syntax to perfect, so we are returning it as 0. So if let's take I want to write this block of code multiple times, like let's take I 10 times I need to write this, okay, as per the requirement. Then what I need to do, I need to repeat this again. So these 4 5 lines whatever are there, no, so in real world there would be many lines of code, so that you need to repeat, so it will create the redundancy, right? It will create the duplicacy, redundancy, and it won't be the optimized code. Okay, so to uh, make it happen, to solve this problem, we means scientist has developed these functions. So what functions will do? Just you need to, whatever the logic is there, you just need to define somewhere that logic. Okay, this full logic you need to define somewhere under the function. Okay, inside the, let's take here you defined one thing is you defined the function here, okay, and in this defined function whole the logic is there, whatever the sum logic we are writing here. Then inside the main function, as many time you want you can call these functions, okay, wherever you want you can call these functions. So what we can understand by this, that you just need to define logic once and use multiple times. That is why the even in C programming it is called as modular programming. Okay, so module wise we always write the code in optimized way. So what we'll do now, we'll just see the syntax, okay, how functions will be returns. Okay, so always see whenever you are calling the function, before that you need to define the functions. Okay, and if you are defining the function before that, you should know declaration of the function. So declaration means you are just notifying the compiler that somewhere this type of function is there, means you just need to write here return type, okay, function name, and here data type and those variables. Okay, this is the declaration. Okay, so the first is declaration, second is definition, function definition. How we write function definition is nothing but same return type you need to write always before writing the function, and write the function name. After that, the data type and where sorry data type or whatever the variables data type is there, that you need to, and inside you need to open this braces, and here you need to write the definition, whatever the logic you want to write here. Okay, here logic code you can write, and if you are returning you can return that whatever the results are there. This is the function definition. Now function call will be there. Okay, this is the whole syntax of the function I am explaining you. So call means just you need to call this function. Okay, so function name and whatever the data type, you don't need to write data type, just you need to write the variables. Okay, so now in whenever first you can, what will happen if you write here definition in the C, this is the C file. Okay, if you write here definition, definition means here your function will be there, one function, okay, fun. Then later if you are writing here main function, okay, and here you are calling this fun in this inside the main function. If you are calling this function, then it's okay. Compiler will see first this definition. It will compile this definition and it will understand, and later it will go to the inside the main function, and it will call this function. Okay, so it's okay. But in case if you have your main function is here, and here you are calling this fun, okay, this is the file, here you are calling, and but you defined after the main function closes, you defined here this function definition, you have this here your function definition. So what compiler will see, compiler will go here and it will see the function it is calling, but nowhere it is written because it is line by line. C compiler will check. So function definition is downside, but here only it will give warning or compiler error. Okay, so instead of this, if this is the case, then what you can do, we can make use of the function declaration. So before the main function, here you can write your function declaration. Means you are declaring that you are informing compiler function has been defined. This declaration means somewhere it has been defined. So whenever it is called, just go and take the function definition and process the logic. So okay, I hope you have understood this one. And whatever the function, whatever inside the definition and call, function call, this is the more important. I would like to discuss further on this. So inside the function definition, whatever these parameters are there, this is called as formal parameter. Okay, formal parameter, and this is called as actual parameter. Okay, or we can say it as arguments also. Means whenever you are calling the function, then you put the actual value or actual variable or the actual parameter inside this braces. But when you are defining that function, you just need to put here as a prototype. Prototype means this is the format. This type of data can enter inside this definition. Okay, so this is the syntax we discussed now. Then further we'll go to the one example I would like to give here, and we can understand the use case of functions as well. So this is again main function I am writing here. So inside main function, if I write here int a equal to 10, b equal to 20, okay, and here I am printing sum is percentage d, that is a plus b, okay, and return 0. So this is the main function. Let's take, instead of writing here, I'll again write here again int c equal to 200, d equal to 500, and I want to print the same sum is, okay, percentage d and c plus d. Again I need to write the sum. So same logic as I am repeating. As I said that we can write the function instead of these. So how this is not a good way, because let's take what will happen. OS will pick up this whatever programs file .c file you have written. It will pick up, and while execution it will put into the RAM. Okay, inside the RAM it will put. So for the RAM some place will be allocated for the main function. Okay, for the main function this RAM is allocated, means this stack will be generated here, and in this stack this a and b whatever local variable you have defined here, right, a and b, and after that c and d, okay, after that and many variables, these variables will last till the end of this function. Okay, so it will last till the end of this function. But instead if you have just a sum function, okay, here I can write here just int sum, here int a comma int b, okay, instead of that we are writing here int a comma int b and return a plus b. Only this much if you write, okay, what will happen here instead of this, we don't need to put even variables. We will just it will call without passing the variable. Here only we will define int a equal to 10, okay, and b equal to 20. You just need to call here inside the main function, you just need to call the sum, okay, and the sum will get called from here from this definition, which is we are not passing any parameters. Here only a and b are there, and it will return the whatever the sum we want, and here we can print. So what is the difference in these both the cases? In the first case, the local variable are lasting will be alive till the end of this program, means sorry, till the end of this function. So means end of the program only. It means these are alive and it is taking the space, so it is wasting the memory, right? There is no use of keeping these variables. We are just we are local variables. Whenever we are using that for the repeated logic, we are using these variables. Instead of this, you can just put the sum function here and define those variable in as a local variable inside that function. So for this case, what will happen? For this second case, main function is there, okay, inside the main function you just call to the sum function. So for the sum function again one call stack will be generated. So inside the sum function a b is there, it will get allocated the space, and at the end of this after the result it will return the value, and it will this misses whatever the space allocated to the sum function, it will get freed. Okay, so it will get freed, and again it will do the whatever the further coding or execution is there. Again when we are needed, when we are calling some function, again it will get allocated the variables, and after the processing, after the logic execution, it will free. Okay, in this second case we can save the memory as well, and no redundant code, and it is more modular and readable as well, right, in an organized way we can say. So this is how the function is useful inside the C program or any program for that matter. After that, now what we'll discuss is we have the two type of classification we did for the function based on the passing value to the function definition. One is call by value, okay, and another one is call by reference. Call means we are calling the function by passing the value. Call means here also we are calling the function by passing the reference, not by value. Okay. How it will be differentiated, I'll explain you by giving one code example. Okay. Well, let's take into let's take void wheel, right? Okay. Void change. We have one function. Okay. Inside this function, I am passing int x. Okay. So here what will happen? Whatever the x value is there, I'll just add x plus 100, and inside the main function, this is the void main. Okay, inside the main function I have int x equals to 10. Okay, and then I'm just calling this function change whatever the x value I'm passing. After that I'll just printf it, printf the value of whatever the percentage d is there, value of x I'm printing. So what will happen in this case? In this case, what will happen, as I am saying that call by value. Call by value means just copy of value will be passed. Okay. So how copy of value? Here I'll explain the memory structure as well for this. Okay. So int x is variable defined here inside the main function. So for the x, let's take some 1000 is the address of this x. And in this x, 10 value is there, right? Now what will happen? We are passing the 10 value, whatever the 10 value, we are just passing the copy of the x, not we are not just passing the address. Means we are not passing whatever the means address of the x. We are just passing the value. So we are just passing the 10 as a 10 we are passing. So 10 will go here. So 10 will come here. After that 10 plus 100, it will be 100. What will happen? 110 it will. Okay, and as here we got 110, after program means after function ends, so this change function ends, then 110 it should come and it should print 110, but it won't print 110 because this is the main function, okay, and this is the change function, whatever we have this function. As we passed the value here, this is start and end. Here inside this function, the x value is 110, but after end of this function, because for this x inside the change function, for this x maybe some 2000 address has been allocated for the x value. So you are changing inside the local inside this function where the variable is local to that function only. So once function ends, then whatever the x variable stored at 2000 it will get freed, and after that here inside the main function, once the change will be end, then again whatever the value was there it is unchanged. Whatever the 10 is there, no, right, the 10 output will get. So this is the just we are passing the value, and here whatever the processing is going here after that it these variables will get freed. After that the same whatever the original value was there it will be printed here. But in this case it is changed. Means how it is changed, I'll explain you. Void main again. I hope you have understood. You just need some more practice on that. So initially it will be somewhat difficult to understand. Okay, this is change. As I am passing here directly, as I said that address of x is 1000 here inside the main function, but as passed a copy to this change function, that's why I am unable to change value in the original address. But now this time I'll just directly send the address of x. We know that we use ampersand here to send that means to get the address of any variable. So as I am passing here, for this memory structure will be inside the main function. Okay, x is 10, its address is 1000. As I am passing directly address to this change variable. Okay, means 1000 as a 1000 I am passing here. So if address of the variable you are passing, okay, here I will print that whatever the x value percentage d and x. Okay, so as I'm passing here address, how the definition will become now? Definition will become whatever the wide change here. How it will be? X is the int type, so I'll write int. Now we can we write here x? No, because it is not variable. It is the address of variable, and we as we discussed that in previous videos that address of variable will be stored in the form of pointer. Okay, understood. So now what will happen? Now we can just take the as a pointer will be, we know that pointer will be defined, value will be defined as asterisk ptr. So same asterisk ptr plus 100. Okay. So by this what we can understand, we are passing 1000 means address of x variable. 1000 means the address of x variable directly original address we are passing, and in that original address whatever the value is there, what is the in that original address value is 10 plus 100, it will be 110, and it is stored in the it's the value will be stored in this star ptr. Star ptr means in the address of x variable. Okay, the 110 value will be stored in the address of x variable, means in the 1000 address only the x value will be 110. Now function ends. After function end, when we are printing, we'll get the value 110 because in the original address only you have changed this by passing the reference. So this is called as call by reference. I hope you have understood this, guys. And finally, we have a small just means based on the return type and parameters. We have four type of functions. This is not a big deal. Just to have better understanding, we have this one. I'm not going to explain more on this. It is just a basic. So how can we write in a four ways we can write functions? First we can write return type. Okay, as we have discussed already, I think this one. So I'll directly give some examples of each. Okay, first will be let's take no parameter here, parameter, and here return type. No return type, no parameter. So how is the function definition will be? Void fun. Okay, this is this void is nothing but the no return type. Okay, and no parameter as we are not passing any parameter. So this is the no parameter, no return type function. And another second type is let's take no parameter but return type we want. So return type means let's take int I want int function. So no parameters means we are not passing parameter. Here just we need to return whatever the result we will get. Okay. Another third type is let's take parameter should be there but no return type. So no return type void function. So parameter should be there. So let's take int a comma int b, and here we are printing sum a plus b like that. Okay. So no parameter, no return type but parameters are there. Then we have another type of function in four way we can write as I said. So here is return type must, parameter is also must. Let's take int again. Okay, int function, int a comma int b. We can just return the sum by writing this logic. So return type is also there and parameters are also there. These are the four ways we can write the function. I hope you have understood, guys. So if you understood something by this, so please comment, like and subscribe, so it will give motivation for us to uh, uh, get more understandable content for you.